Good morning, friends. It's my pleasure to be a part of this session with you all. And in this presentation, we would like to give a demo on how a statistical package can be used in metric studies. And you know very well, when we talk about scientometrics or bibliometrics, we talk about quantum of literature and we talk about quality of literature. When you have a lot of quantitative data, pretty sure these quantitative data can be put into various kinds of statistical tools. Lot of statistical procedures can be conducted on the numerical data, the quantitative data that we obtain in various bibliometric studies. For example, you can calculate mean or average value for many of the factors, many of the variables, many of your questions. So average authors per year, or average authors per paper, or average citation per paper, average citations per year. So there are a lot of occasions when you would be calculating mean or average values. And sometimes even you can calculate standard deviation for your quantitative variables. See, standard deviation tells you to what extent your data is spread, whether it is so widely spread or it is narrowly spread or it is not spread in the sense all the observed values are very close, they are around the mean value, they're not very far from the mean. See, if you take the average citations of a particular literature, can find out to what extent the citations, the observed citations of various records, whether they are close to the average citation or they are away from the average citation. So you can calculate standard deviation of citations and all. And in this session, I would like to concentrate on only one aspect called correlation studies. You know, friends, correlation is nothing but a statistical method of analyzing the existence of linear relationship between two numerical data. So we need two numerical data, any set of two numerical data, maybe something like number of authors in a year, a number of papers published in a year. So these are two different numeric data. Or something like number of articles published, maybe for a period of 10, 20 years, and number of citations received in those 20 years. So these are two sets of data. And both are numeric in nature. And when you want to study the linear relationship of these two variables, these two numerical variables, we can conduct correlation. Fine. See, what is linear relationship? It says that when one variable increases, the other variable also increases. When one variable decreases, the other variable also decreases. This is a kind of linear relationship. It is a positive correlation. In the other way, when one variable is increasing, the other variable decreasing. So that is also a linear relationship, but that is a negative correlation. So this kind of positive or negative correlation existing between two numerical sets of data can be analyzed using correlation. To do correlation, you can use any kind of statistical tools, either online tools or offline tools or free softwares like PSPP or SOFA, or you can use commercial softwares called SPSS. Right? And basically we have two different, not two, you can say three different types of correlations. One is bivariate correlation, then partial correlation, and there is something called multiple correlation. So these are three different kinds of correlations. But I would like to give a demo on only these two things, bivariate and partial correlation. See, bivariate correlation talks about the existence of linear relationship between two variables. And in partial correlation, instead of two values, we take three values. You take three variables, three sets of numerical data, but you will analyze the existence of relationship between two variables, controlling the effect of third variable. See, for example, we have number of papers in published over a period of time, number of total citations received, a number of self citations received. These are three different variables. Now you can conduct a bivariate correlation to find out the relationship existing between total papers published and total citations received. Or you can conduct a bivariate correlation between total papers published and total self-citations received. You can conduct. Or you can conduct a bivariate correlation between total papers published and total citations received, or between total citations and self-citations. So any two variables can be taken for analysis under by means two. But when it comes to partial correlation, you take all the variables, number of papers published, number of total citations received, number of self-citations received. But in partial correlation, we study the correlation between the papers published and the total citations received by controlling the effect of self-citations. So we won't go on to the effect of self-citations and the total citations received by the authors. So to demonstrate these two statistical analysis, let me get into SPSS package. Let me go to SPSS. I got version 23. Now I've got some data in Excel. Let me copy it. Okay, I'll go to SPSS. This is MS Excel. Here you can see I got a lot of pairs of data. Just I would like to give an example of what are the various variables on which you can conduct either bivariate or partial correlations. See, year of publication and number of citations you can conduct. Year of publication and number of citations in some other field. Authorship pattern and number of papers published you can conduct correlation. Total citations and self-citations you can conduct bivariate correlation. Number of authors and number of self-citations you can do a correlation study. Number of local citations and number of global citations you can conduct a correlation study. Number of countries in a continent and number of papers proportionately published by them. You can take these two variables, you can conduct bivariate correlation. And you can take number of papers, total citations and self-citations. You can take these three variables and you can conduct bivariate correlation and partial correlation. And number of papers and number of pages, you can conduct bivariate correlation. Total citations of the authors and Hutch index of the authors, you can take these two variables, you can conduct bivariate correlation. Number of cited references and number of citations. You see whether there's any linear relationship between these two variables, you can conduct bivariate correlation. Or number of citations and usage count, you can conduct bivariate correlation. Papers published and papers cited, you can conduct bivariate correlation. Number of cited papers, number of citations, you can conduct bivariate correlation. Authorship pattern, number of papers published, number of citations received, you can take these three variables and you can conduct bivariate correlation and partial correlation. Right. So these are a few examples of variables on which we can conduct partial and bivariate correlation. So let me take this particular data. I got three sets of data. First is number of papers published by authors over a period of time, total citation received by those papers, and number of self-citations. So let me copy this data and let me go to SPSS. I just paste it. I think it's pasted. So remember, first is number of papers, then total citations, then self-citations. Okay. So let me just go to data view. I just name the variables. One is number of papers, total citations, and then self-citations. Fine. So three variables I have. Okay. This is just for our understanding: papers, total citations, and self-citations. Okay, now you can see here papers, total citations, and self-citations. Now let us conduct a correlation study. So you need not just use SP, you can use any statistical package for conducting these correlation studies. So let me go to analyze. In analyze, I'll go to correlate. I collect bivariate. So analyze, correlate, and I go to bivariate. I have to find out the relationship between number of papers published and total citations received. So I have selected both the variables for which I want to find out the existence of the relationship. Here click Pearson. Pearson is the most popular bivariate correlation test. Say options. If you want mean and all, you can take it. If you don't want, just leave it. Say OK, and you get a result. So result is here. It says that The correlation between papers to paper is 1. The correlation to papers to total citation is 9 to 9. See, 9 to 9 is a very good correlation. That means that there is a very good positive correlation between number of papers published and number of citations received, because the R value is 0.929. Since it's 0.9, it is a positive correlation, and since it's 0.9 very close to 1, we can say that both these variables are closely related. And there are 19 years data, and it says that the two-tailed p-value is 0.000. It means that there is a significant association between the number of papers published and number of citations received by them. So, if you are trying to prove the hypothesis, you can say that the null hypothesis is rejected and the alternative hypothesis accepted. That is, there is a correlation between number of papers published and the total citations received by them. Fine. So same concept, same results are repeated here. So this is a simple way of checking the existence of linear relationship between two variables. Fine. So let me try the other one also. I'll go to analyze, I'll go to correlate, I'll go to bivariate. This time, let me check the correlation between total citations and self-citations. Is there any correlation between, is there any linear relationship between total citations received in a particular year and self-citations received in that particular year? So I just say, okay. Once again, you can see there is a very good relation between total citations and self-citations, and the result is very positive, and it's very close to 1. So once again, it is proved that there is a very, very high positive relation between total citations and the number of self-citations. Fine. So this is about bivariate correlation, where we analyze about two different variables. So now, for example, now I would like to conduct a partial correlation. In the sense, I want to study the effect of the correlation between number of papers published and the total citations, keeping or controlling this factor. So I'm going to control the effect of the variable self-citations, and then I want to see whether there is a correlation between papers and the total citations. How to conduct a partial correlation? Please go to analyze, correlate, and there is an option called partial correlation. You can click on partial, and it says that what are the variables and what is the factor to be controlled for. Here I select variables papers and total citations, send them to variables box, and I select self citations, send it to controlling box. Fine. So here we try to explore the linear relationship of two numerical data controlling the effect of third numerical data. Fine. So I just click the 2 times, automatically appears on the calculator. I say OK, and you can see the result here. See, since both are very closely correlated, you have seen 9.929.929 in both the ways. It means that there's a very close association between the three variables. That is why it is the system, the software is not able to exactly whether self-citation is having an effect, controlling effect on other two items. So there is no answer in the sense the items are, all the three items are very closely related, so that you cannot separate the effect of self-citations on these two variables as far as this particular example is concerned. So either you can conduct bivariate correlation or you can conduct self-citations. For example, here let me make a small change in the data. Fine. I just make some changes in the data, and then let us see whether that will have some effect on the partial correlation that we will be conducting in our next example. Fine. So now what I've done is that I have made small changes in the total citations received and the total self-citations received. So papers and total citations, let them be as such. I made some corrections in the self-citations. Let me rerun the partial correlation once again. Let me go to analyze. I go to correlate. I select partial correlation, and the variables by default they are there. You can say OK, and here you can see here. See, you got the answer now. see the relation between papers to papers, the relation between papers to total citation, and the reverse one, the bottom box. You can see here the result is significant. It means that when the result is significant, it means that when the factor of self-citation is controlled also, there is a close correlation between number of papers published and number of total citations received. So this kind of conclusion will come to understand by calculating the partial correlation, not only in SPSS, in any of the statistical softwares we have. So the metric results have got lot of quantitative data. What kind of analysis you can conduct, it depends on your imagination. I just thought of sharing with you all how these kinds of related numerical data can be put into a correlation test in SPSS. So thank you so much for watching this particular lesson. Let's meet again.